now we're getting into antiderivatives. And before we even think about what an antiderivative actually is, let's just talk about some big picture items for this. Now, the crux of this question is this. Let's say f of x is equal to x. And I'm going to tell you that f of x is a derivative of a, and I'll put it in parentheses because it's not really what it means, a larger, or we can say, or in higher, not an, a higher order function. Something above f of x equals x. Now, the weird notation for this is, since f of x is a derivative, it comes from a different function. And I'm going to say, to make matters totally confusing, I'm going to make a capital F. And it's going to be f prime of x. Capital F prime of x is equal to my derivative. This is the derivative function. And this is the whole idea of it. You get a function, f of x is equal to x. Then you ask yourself, or then you're told, hey, it's this dude's a derivative of something. We don't know what that something is, though. Then you ask yourself this question. What is x a derivative of? So now we become detectives, and we have to try to figure out what would give us the derivative equal to x. So what function gives us a derivative equal to x? That's your job. And that's what we have to do. Now, what's things that we want to think about? Things that we want to explore. Make that a little bit bigger. Alright, x is to the first power. Now, derivatives, what happens to the power with derivatives? Well, powers decrease when you take a derivative. Think of x squared. If y is equal to x squared, what's y prime? That's 2x. Alright, so that's a start. We have y is to the first power, we know, or x is to the first power. We know x is going to end up being to the second power. So, see what happened though? If it was just x squared, we would have got a 2x. Maybe we could think of it like this. Alright, well, maybe the original was this. Ax squared. Because what's the derivative of this? Screen froze, hold on. Alright. Now notice, again, I'll backtrack just a little bit. 2x. When we took the derivative of x squared, we got 2x. But our function was x. So if I said, well, let's put an a in front of the x squared, because now y prime would be 2ax. Well, if f of x is equal to x, and I know that the derivative of ax squared would be 2ax, well, these two things would be equal to each other, because I want a derivative to be equal to this. So I could say 2ax is equal to x. Now if we divide by x, x's divide out. So I get 2a is equal to 1. Divide by 2, divide by 2, a is equal to 1/2. So this leads me to believe that if f of x is equal to x, which is equal to capital F of f prime of x, let me move it over just a little bit here. Now the big daddy function, f of x, big F of x, we get this, 1/2 x squared. Now, check it, take the derivative. F prime of x is equal to 1/2 times 2x, which is equal to x, which works. Now, I'm going to end with a cliffhanger. So we figured out f of x, which is what we call an antiderivative. It's an antiderivative because it does the opposite derivative. It gets us back to the higher order function. We figured out it was 1/2 x squared. So our higher order function is 1/2 x squared. This isn't the only one. I'm going to be nice and quiet and say what we'll learn in part 2 is that there's this many versions of this function. And in part 2, we'll talk about why.